Good evening, everyone. This is Unit 2 of IAL Physics, June 2016. So, in the first question, which of the following are two SI base unit? So, ampere is there, but hertz is a drive unit. Ampere is there, and second, both are the base unit. So, B is the right answer. Coulomb and hertz both are drive unit. Coulomb is there, and it's a drive unit, but second is the base. So, B is the right answer. Which of the following type of wave has the highest frequency? So when we write the electromagnetic spectrum, we have radio, micro, infra, visible, the only part which is our eyes sensitive or detect, ultraviolet, X-ray, and then gamma. So when we move from radio to gamma, what we observe the frequency will increase and the wavelength will decrease. So we have option infrared, micro, radiant, ultraviolet. So ultraviolet is having the highest frequency. A sound waves are classified as longitudinal waves. So why we call sound waves as longitudinal waves? Are produced by vibration or produce displacement along the direction, because the difference between longitudinal and transverse, the displacement is perpendicular to direction of travel of wave for transverse, but in longitudinal the displacement is same as or parallel to direction of energy transfer or the travel of wave. It requires a medium, so that is mechanical basically, and transfer energy along the direction of travel of the wave. So it's not about transfer of energy, because the energy transfer direction is considered as a direction of wave. So it's direction or vibration of the particle produce displacement along the direction of a travel of wave. For question 4, two speakers are there which are 11 meter apart and producing a sound with a wavelength 2 meter. So we'll calculate the path difference. So this is 5 meters from S1 to X, and the other one, that is 6. So the path difference between them, it will be 6 minus 5, which is equals to 1 meter. And in terms of wavelength, what is the difference? Because one wavelength is 2 meters, so 1 meter is equals to half wavelength. So when there is a half wavelength, 1 by 2 or 3 by 2 or 5 by 2, it will be a destructive interference, or destructive interference means that two waves will be anti-phase. So that's why C is the right answer. Because they are not traveling in the same direction, that's why the wave from S1 is pi radian ahead. These two statements are not valid according to the question, because if they are traveling in the same direction, then we can work out which one will be ahead or lagging. In question 5, standing waves are created in a pipe. The pipe is closed at one end. So if the pipe is closed at one end, the pattern of vibration which is produced, it will produce node and antinode. So distance between node and antinode in terms of wavelength, it is lambda by 4. So length of the pipe, which is L, that is equals to lambda by 4, or we can say wavelength is equals to 4L. So what is the wavelength of the corresponding lowest frequency? Lowest frequency in this manner, that's equal to 4L. The light ray travel in a medium 2 meets the boundary in medium 1 at an angle of incidence theta. The critical angle for a light for medium 2 to medium 1 is C. So which of the following statement? If no light is reflected, there is partial reflection and refraction when the angle of incidence is even equal to or less than critical angle. But if this angle is more than the critical angle, all of the light will reflect and no light will transmit. So no light transmit when the theta is more than the critical angle. C is the right answer. When the surface of a metal is illuminated with a particular wavelength of light, electrons are emitted. Which of the following statement is not true? Decreasing a wavelength below a certain value causes electron emission to stop. If we decrease the wavelength, it means we increase the frequency, because we have the formula E is equals to hc over lambda. So if we are decreasing a wavelength, it means we are increasing the energy of photon. So photoelectric effect will not stop. So A is the right answer. What about other options? Electrons are emitted at a greater rate if the intensity increase. That's true. Increasing intensity will increase the number of electrons emitted out. Maximum kinetic energy of electron is photon energy minus work function. That's also true according to Einstein equation. Work function is the minimum energy required to release electron from the metal surface. That's also true. Question 8. The light of frequency f and speed c is moving from air into a transparent medium of refractive index n. What is the frequency? Frequency does not change. So if originally frequency is f, in the medium it also remains f. The diagram shows a block of a conducting material. When a potential difference is applied across 8 centimeter, so the length through which the charges have to flow, that was 8 centimeter, and the area 4 multiplied by 4, that is equals to 16. But now same potential is applied across opposite faces of 4 centimeter. So if you apply, now the length which it has to pass through, that is 4 centimeter. But what about the area? Because this one is 8 and this one is 4, so 4 multiplied by 8, that's equal to 32 centimeter. So length, what happened to length? Length is decreased by 2. And what happened to area? Area is increased by, as you can see, this was 16 originally, that will become 32. So area is increased by 2. Now the question is, the original current and the relation resistance is directly proportional to length. So if resistance length decreases, resistance will also decrease by 2, and resistance is inversely proportional to area. So if resistance area is double, resistance will be half. So both changes cause the resistance to decrease by 2. So the total change in resistance will be by 4. And resistance and area are in resistance and current are inversely proportional. So if resistance is decreased by 4, then the current should increase by 4. That's why D is the right answer. Or you can also use the formulas we have, like, because the same potential V is equals to IR, so I1 R1 is equals to I2 R2. I1 is the first current, which is I. R1 R is equals to rho L divided by A, and this I2 we don't know, that is equals to rho. Length become half, so it will become 0.5 L. Or you can also substitute the value compared to original one. Instead of using the coefficient here, you can like write L1 and L2. So rho L2 divided by A2. And where L1 is 8 centimeter and A1 4 multiplied by 4, that's 16 centimeter square. L2 is equals to 4 centimeter and A2 is equals to 8 multiplied by 4, that's equal to 32 centimeter square. So you can substitute the value and you will get value for I2 in terms of I1, which will come out for I1 or 4I. A student set up the following circuit where X is unknown component. The cell has negligible internal resistance. The student wants to produce a current potential graph for component X. What change need to be made in order to collect the data? So what he should do, because To plot a graph, we need different values. So to get a different value of voltages, we should change the circuit resistance. How we can change the circuit resistance? By adding resistance in series. Because when we add resistance in series, the potential here will change. So the current across the component, the circuit will also change. So B is the right answer. So add a variable resistance series so that we can change the voltage and current and plot a graph from the set of results. So this was Unit 2 of IAL Physics, June 2016.